For your solution for page 175, numbers 2 and 3, we have a bird sitting on a tree. We have a hanging sign. Yep, hanging up. Okay, and it wants to know the mass, and this one wanted to know the height. So we're not going to use the EP equals something, but we are going to use a version of that. Okay, so thank goodness we have our formula sheet handy. Okay, so we already have our formulas rearranged. Okay, and we can choose which one we need. Okay, so the first one went like this. And it went like this. Okay, so the mass was 800 grams. Potential energy they gave us is 47. The height we don't know, and we should put the units. Okay, so that we know what we're looking for in the end. And the gravity is always the same. Okay, and they didn't give us gravity, but we know we're doing potential energy questions, so we know to put gravity on there for you. Okay, so we're going to use the height one. H equals EP over GM. Okay, and a tip that you want to do that's mathy, okay, is the bottom ones first. It's just a good habit to do, it's called bed mass, right? I don't know if you remember that from math class. Okay, you do, I don't remember what they are, brackets, exponents, something. Oh, division, multiplication, adding, subtraction. Okay, yeah, so that you get the right number. Okay, I like to do these two on the bottom first. Okay, so I go 800 times 9.81. Okay, is that? And then I do 47 divided by the answer. And we have these neat buttons on the calculators that go answer, right? So instead of typing in that number, you can just go 47 divided by, and you go shift, answer, okay, and it even says answer. Then you push go, and it gives you your answer with exponents. Isn't that nice? So you write out this whole thing, 5.98, blah, blah, blah. Okay, times 10 to the negative 3, 5.98, blah, 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 times 10 to the negative 3 meters. And then you're going to round that to 3 significant digits because you only had 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. So your answer has to have 3. So 5.98, blah, 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 rounds off to 5.99. And let's make our 9 look pretty. Okay. So that our answer makes sense. Okay, times 10 to the negative 3 meters. So what does that actually mean? 5.005999. Okay, but we like scientific notation because this is science class. Good morning, Betty. Okay, so number 3, they gave you a height of 3 meters. They gave us a potential energy of 1.47 times 10 to the 3 joules. Okay, and if you're like, hey, I want that in non-scientific notation, I want that in normal numbers. Okay, that just means you move the decimal over 3 times. 1, 2, 3. Okay, add a 0 for any place that you run out of the numbers for, and that's a 7, not a 3. Joules. Okay, so if you prefer to change it all the time, you can, but that'll take too long. And you want to get used to scientific notation because that's what we do. Okay, mass is what we're trying to look for. Gravity, we always know, even though they don't usually put it in the question. Okay, and this time we're looking for mass. So we use our mass formula from our mass cheat sheet. Okay, so mass is potential energy divided by height times grams, and it doesn't matter which one these go, right? It could go G times H or H times G. And so your mass is this divided by that times that. Okay, so again, I like to do the bottom ones first, just personal preference. Okay, let's put this up a little bit. Okay, what was it? 3 times 9.81. Okay, just a little bit less than 30. Okay, and then 1.47. Okay, so how you put that in your calculator is you push 1.47, and on my calculator, you push shift, this 10x button. Okay, so I get the little 10. So So times 10 to the 3. Okay, divided by answer is 4.994, blah, blah, blah. Okay, so you write that down, 4.994, blah, 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 and grams. And you're going to round that properly to 3 significant digits because you had 1, 2, 3, 1, 2, 3, 1, 2, 3. And so we're only allowed 3. And I would like to round this off to 50, and that's what I did, but you're not supposed to. Okay, so, because the 4 rounds it down to a 9. Okay, so your final answer is 49.9. Right? Well, that's how you do potential energy. Okay, now let's move on to kinetic energy next. Okay, same basic concept for how to do your formulas. You have listing your variables, putting your formula, plugging in the numbers, and reporting your answer with significant digits. Okay, so depending on how fast you're going, okay, that is going to give you your kinetic energy. So luckily for us, we don't have to add any variables to our list because we already had speed from yesterday when we were doing V equals D over T. We had M was mass, which we've worked with a couple times. E is for energy. That's going to be measured in joules. Okay, so let's just add, this is the unit analysis. Okay, let's add the formula, this one, okay, to our formula sheet and do some practice. Okay, so potential energy, we had. Okay, now let's put kinetic energy on there. What color? Let's make it red. What color box? Let's put blue. Okay, so this is kinetic energy. Okay, and rearranging these formulas is a bit more of a nuisance because you have this half thing. Yeah. Yeah. Okay, I think that's how it goes. And if I need to correct that after, we'll fix it. Okay, so let's do some practice and finish that PowerPoint a little better. Okay, so if you have a ball, you push it horizontally for 20 meters per second at the speed, okay, then find the energy. So you would have, using this new formula, okay, so half of mv squared. So what we're doing here is we're going 0.5 times, I like putting 0.5 instead of divided by 2, but that's just perfect personal preference. Okay, so 0.3 times 20 divided by 2. Okay, and it should be the same answer. Okay, it's fun to check our calculators though. Okay, so 0.5 times, what was the question? 0.3 and 20. 3 times 20 is 3. Okay, and let's see if that's what was in the answers. Oh, they put 60. Let's see what changed. What did we do differently? How come this says 20 meters squared per second squared? That's really weird. Must have typed it in weird. Like 400 meters squared. Oh, because you got to do exponents. Ah, there we go. That's what we missed. Okay, you had to do speed squared. Okay, I forgot all about that. So let's fix it. Okay, that's why it's always good to try it on your own first and then correct it. Okay, and showing your work is important too. Okay, so let's go back to our calculator and move this so we can see the question better. Oh. Yeah. Okay, so let's put it actually over here. Trying to make it so we can see both. There we go. Okay, so we should do 20 first. Okay, 20 squared. Let's see if I can find the button for that on my calculator. Oh, there it is. Okay, so 20 squared. Okay, times 0.5 times 0.3. 60. There we go. Okay, so that's new. We haven't done that in a while, or in a really long time. Okay, so that v squared is very key so that we don't get it wrong. Okay, so the next question said, what's the kinetic energy of an 87 kilogram bike if it's ridden at a speed of 12 kilometers per hour? Okay, and you're looking at this saying, what's going on here? How come we have 3.33 meters per second squared? That doesn't look like the right speed. Oh, let's see if we can figure out why. Per hour. So we need to figure it out in seconds. Okay, I'm going to need to write this down on a piece of paper because I can't do it off the PowerPoint. Okay, I need to write things down, and that's okay. So on my paper, okay, I'm writing right beside. Okay, I am putting the variables. Okay, so we want to know EK, and that's going to be measured in joules. They're giving us speed, okay, which is 12 kilometers per hour. And they are giving us a mass, 87 kilograms. Okay, so let's switch over to this so you can see it. Okay, so step 1, list your variables. Step 2, put in your formula. Okay, and let's put this in seconds. Okay, so how many seconds is there in an hour? Okay, there's 60 seconds in an hour and 60 minutes.